Hello, now let us solve the problem. So we are supposed to find all primitive functions of this given function. If you have a lot of enough experience in actually calculating primitive functions, you will realize that immediately this is a good idea to rationalize the denominator of this function. By rationalizing the denominator, I mean write an expression which is exactly equal to this one, but it doesn't have any surd signs, any radical signs in the denominator. To do that, I just rescale this fraction by multiplying the numerator and the denominator by the conjugate of the denominator. So what do I mean by that? I just copy and paste my expression and then I multiply both the numerator and the denominator by an expression which forms the conjugate rule for the denominator. So it means this expression, yes? Which of course here coincidentally is exactly the numerator itself. So what happens if I multiply that? This numerator will be multiplied by this numerator because they are the same. It becomes the same expression squared. And this denominator multiplied by that denominator forms the conjugate pattern, so it becomes the first one squared. So then I get rid of that surd sign, and then minus the second one squared, x squared. Okay? And then this x squared and that x squared are cancelled. I'm just left with just single number 2. So it means that in principle, I do not have any fractions at all that makes trouble for me. So what I do, I just write it as 1/2, because this x squared and that x squared are gone. 1/2, I wrote 1/2. Then I raise this one to power 2. So the first one squared becomes x squared plus 2. And then 2 times the first one times the second one becomes minus 2x square root of x squared plus 2. And then plus the second one squared, which becomes positive x squared. And then I do a little bit of simplification. So you see that this 2 multiplied by 1/2 gives me 1. And then I have x squared here, x squared there. It is 2x squared multiplied by 1/2 is just simply x squared. And then I have a factor of minus 2 here. When I multiply 1/2 in, that is also gone. So I will get that expression. Okay, so this is exactly the function. So it is written in a very nice form so that I can integrate it immediately. So the integral of my function, whatever it is, so if you don't mind, let me call it f of x. So the integral of f of x dx is equal to the integral of that part, 1 dx, plus the integral of the second part, which is x squared dx, minus the integral of the third part. So it is x times x squared plus 2 dx. Yes? Okay, so these two integrals are extremely simple. That is also a very simple integral if you are already familiar with the method of substitution. Yes, so what we do, so let me just integrate these two. So the answer to this one is just simply x. The answer to this one is a third x to the power 3. And then let me write minus I. So I am giving the name I to this integral. And I want to calculate this separately. Okay, so what can I do? In order to calculate I, so let me write I in front of our eyes here. X squared, x times square root of x squared plus 2 dx. Okay, so method of substitution here works because here x squared plus 2, if I ask you what the derivative of x squared plus 2 is, it becomes 2x. So you see that x up to a multiplicative constant 2 appears somewhere in the integrand as a factor. So whenever this happens, that one part of integrand, the derivative of one part of the integrand appears as a factor in the other part of the integrand, that is usually good to think about the substitution method. So I would say that let u represents a square root of x squared plus 2. Okay, and then I square both sides. U squared becomes x squared plus 2. Then I differentiate. The derivative of that one is 2u du. The derivative of this one is 2x dx. and I divide everything by 2, so this means that u du is equal to x dx. So this means that, so this is multiplication, so this x times dx can be written as u du, and then instead of this instead of this square root, I can just simply put u. So then it becomes the integral. So this part is u, this part x dx is u du, which is integral of u squared du. But now I am integrating u squared. The variable is also u, so it is extremely simple. So this becomes 1/3 u cubed. And now I replace u with my original variable. So this becomes 1/3, the second root of x squared plus 2 to the power of 3. And if you want to, you can write it as 1/3 x squared plus 2 to the power of 3/2. Okay, so now the question mark that we were looking for, we already had these two parts. Now I have calculated I, so I just combine them and I have my solution. So this becomes x plus 1/3 of x to the power of 3 minus 1/3, and then I have x squared plus 2 to the power of 3/2. And of course, it has mentioned that find a primitive function. If it's a primitive function, you really don't need to put this c. We can choose c to be 0. And if you are interested in finding all primitive functions, as in this problem, we have to respect this phrase in the question and show that we know about this, and we put c here. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.